Okay, Betch. Good evening. It's 17:30. Time to start. Uh, I hope I'm loud and clear and hope the screen is visible to everybody with introduction to ChiefMate Phase 1 chart work on display.
Yes, sir.
Okay, good. Guys, there are still some more to come in. As of now, I expect, including my own self, 31 candidates plus myself. That means total 32 in the meeting. I can see on the screen 25th one coming in now. So that means another seven somewhere still lagging behind. Anyway, that's not the issue. Now, first and foremost, let's agree on certain ground rules so that we are able to effectively deliver the content. Guys, I have just received a message from Airtel. There is some internet upgradation job which they are doing. So my office internet is already down. I'm on my residence internet now. So if there is a disruption, that could be because they are upgrading the system. So don't get panicky. It could be a disruption, but hopefully it should not be because one internet is down, the other one is working for sure right now. Now, some of you might have attended some module with me earlier. They are conversant with the way we operate. Now, as far as whatever component I need to cover with you, that is the chart work. The navigation part will be done by Sunil Bhaba. Now, whatever classes I have to take with you guys, usually what I do is
I cannot hear you.
Sir, you're inaudible, sir.
Sir, cannot hear you, sir.
I think internet चला गया यार.
okay, guys, I'm back in the meeting. I think there was my fear was about the internet disruption, and that's exactly what happened. I hope I am loud and clear again. I'll just share my screen. Can you confirm if I'm loud and clear, guys?
Yes,
Yes,
sir.
sir.
Yeah, there was a momentary disruption. So my that's what I had sounded you off about because they are upgrading the internet services right now. Why is it not sharing now? Something or the other keeps coming up. Let me close this one. Guys, I'll just log out and log in again. Give me a minute. I'll just leave the meeting and I'm joining you again. Okay, guys. Where I was lost when I started off was that let's try to connect 5 to 10 minutes ahead of the scheduled time so that if there are any technical glitches, they can be resolved. I will start the delivery exactly 5 minutes after the start time. So if the start time is 17:30, at 17:35 I shall start the delivery. The 5 minutes which I have added is not to change the starting time. Starting time remains 17:30. This 5 minutes is only to allow for last minute issues. So please don't think that 17:35 is the starting time. No, 17:35 is the time when the delivery would start. So my request is please join in time. Number two, please keep your videos off because here we have come out of choice. So I expect all of you to be serious about it. So there's no need that I need to see your faces or mark your attendance. It's an optional thing you've opted for as a support system, and I'm sure you'll be as serious as I would be and as keen as I would be in teaching you. Number three, you need to keep yourself muted. You can unmute anytime whenever you have a doubt. You don't have to wait for me to stop. You can unmute and shoot your doubt out whenever it is. If I feel that is the right time to respond, I'll do it, or I'll ask you and I'll convey to you that I'll be addressing that in a while and we can continue. But you don't have to worry about, you can just unmute, share your doubt, and then mute yourself back so that we don't distract the class. It's also important that you remain muted because many of us may not have a private room at at our homes. We live in social setup at home. So sometimes when you leave yourself unmuted, your background noise and the privacy of your house is also at stake because people are able to hear what is happening in the background. So it's in everybody's interest that you keep yourself muted unless you are communicating with me. Now, as far as chart work is concerned, I will not assume that you know anything. I'll start right from scratch. I'll also revisit what you have done in second mates at pre-C level so that all that does not become a hindrance to our learning. And believe me, more and more questions are now being asked from what you have already done. Therefore, it's imperative that we revisit everything that was done earlier. So I'll start with from scratch, and I'll take you through everything. Wherever you have doubt, please do not hesitate to ask. When we start doing questions, I will be asking you questions. Be interactive. The more you interact, more you would learn. Sometimes you may speak something wrong, never mind, at least, but just don't speak for the sake of speaking. Speak something that comes to you as a response to the question. And the more you interact, more you will learn. If you're right, that's good. If you're not right, it will give you an opportunity to correct yourself. If you remain in silence, if you remain hiding behind everybody, you will never know whether you know the stuff or not. So my suggestion would be interact as much as you want and can when we are going into the question mode. With this, guys, I'll start my first part of the presentation, that is basic introduction. Now, all of you know that chart work forms part of terrestrial and celestial navigation exam for phase 1. There are 3 questions from the chart work component. Each question carries 25 marks. That means chart work carries 75 marks weightage out of 200 in a paper where you need 140 to pass. So it's an important component for both from professional shipboard utility point of view as well as examination perspective. Sometimes people say, sir, why should I know chart work now? We have ACDIS on board. Guys, we welcome every technological advancement, but please do not forget that whatever you're doing on ACDIS, you will be able to perform better if your fundamentals of chart work are in place. So even the use or and utility of ACDIS would improve if your fundamentals of chart work. I'm talking of fundamentals. I know there are some obsolete methods which are coming in the exam and nobody wants to would have ever used them. Now that besides the point, but the fundamentals always remain important. So I'm a strong believer of the fact that fundamentals, if in place, they will help you whether you are using ACDIS or you are using paper chart. Okay. Now, the charts used in the exam, I've already shared these numbers with you in the uh, that introduction to the course that we are talking about. Now, as far as the class is concerned, we shall cover the entire thing on 5048 so that every day we are not having confusion about which chart to have today, sir. In the class, you need to have 5048. Other charts you need to have so that you can practice the past papers. Do we need the chart today? We do not need the chart today. When do we need the chart and the plotting tools? After in the fourth class from now. So today is the first one, then you have the second one tomorrow, and then you have the third one day after tomorrow. In these three classes, we'll be covering the basics. And from the fourth class onwards, we'll start plotting. So you need to have your charts and chart work tools, plotting tools, ready by the fourth class, guys. If you don't have the chart, let me know. I'll share the soft copy. You can go to a good printing press or a photocopying shop where they can print it on a big paper. Or if you can source from a bookshop or somewhere, that's the best option you have. But please make sure you source all your charts and chart work tools by the time we hit the fourth class. First three classes, I'll not need the chart. Okay. Now, the chart that we'll use in the class, as I've already said, we'll be using BA5048. The chart would look like this. In the chart, this is the title of the chart, that is Old Head of Kinsale to Tusker Rock is the title of the chart. Here you have the units of depth. The depth on this particular chart and the other charts that you'll use would be in meters. The depth is also unit of depth is also given here. You also have the scale of the Mercator chart in latitude 53 degrees here. What I like to draw your attention are a few important things in this box. One is the depth. You can see the a remark about the depth here. Depths given on the chart are in meters. And what is the reference from which the charted depths are given? They are given from chart datum. And what is chart datum? Chart datum is usually the lowest astronomical tide. That means under normal meteorological conditions, the lowest level that the tide would reach is your LAT, lowest astronomical tide, and that is the chart datum. So if somebody asks you a question, what is the reference from which the charted depths or the depths of the sea on chart are given? Your answer has to be chart datum. So the reference from which the depths are measured is the chart datum. Right below the depth are the heights. You have the heights of lighthouses, towers, and high objects given on the chart. Heights on this chart are again in meters and they are given above mean high water spring. So, guys, reference for the depth reference for the depth is the chart datum, and reference for the heights is mean high water spring. So the references are different. Chart depths are measured from chart datum, and charted heights are given above mean high water spring. Drying heights are the ones which sometimes get submerged, sometimes come out of the water in low tide, and they are given with uh, drying heights are given with a underlined thing. I'll show you when we reach a chart where drying heights are marked. Don't worry about that. So what is the takeaway from this box? That the reference for the depth is the chart datum. The reference for the height is the mean high water spring. Rest is the projection is the Mercator ILA that we don't need for this our chart work. That's okay, but you can always refer to these. These are the tidal streams here. This is the one I'll talk in detail in my last lecture when we close out the chart work component. We'll talk about how to use these tidal streams later on. So these are the tidal streams, and we'll talk about them later in the last lecture as we close the chart work component. Now, if you see the scale here, the latitude scale, it has two different markings. One is this 52 degrees 0 minutes, 5 minutes, 10 minutes. This is one scale. Other scale is this one, this one, this one, this one. There are two different scales. We will be using the one that I have circled. What is this other scale? This other scale is this. It is the National Grid of Ireland. It's a Irish Navy. They have this special grid. So the other scale marked, which has been ticked here, this is not to be referred to when you're plotting. So don't get confused which chart to what which scale to use. Likewise, on the longitude side, this is the scale we'll be using. Sorry, not this one. Uh, but this is the scale we'll be using, right? This is the scale we'll be using. This is not the scale we'll use. This is not the scale we'll use. So we have to be very clear which scale are we going to use. The other scale, I've already said, it is the scale of the National Grid of Ireland, which is not to be used by us. We have to use the latitude and longitude scale, which is circled both on the vertical axis as well as the horizontal axis on top. Any questions on this that is on display, guys? Of course, we are this again. I'll talk with this together in the last lecture. And then this has nothing to do with our chart work. This is the general direction of the voyage, that it is ILA A system, red to port, green to starboard when you go in the general direction of the voyage. So the general direction of the voyage is shown by this arrow. From chart work perspective, important takeaways: unit of depth, reference for depth; unit of height, reference for height; tidal tables, and the scale which is to be used. These are the important takeaways from this particular slide. Any questions, guys, on this slide which is on display? Or is it okay? Class, is it okay? Okay, fine.
No doubt, sir. No doubt.
Okay, fine. Now, basic features of Mercator chart. On Mercator chart, we already know all meridians come as vertical straight lines and they are parallel to each other. If you see, the meridians are equispaced on the Mercator chart. That means the spacing between two consecutive meridians remains the same on a given Mercator chart. Of course, it will vary from chart to chart, but on a given Mercator chart, the spacing is constant. For example, you see on this one, these are the meridians. This is one meridian, this is the other meridian, this is another meridian, here this is another meridian. They are all meridians. Vertical straight lines are the meridians. When we say spacing between them is same, so if the distance between these two meridians is x centimeters, distance between these two would also be x centimeters. Distance between these two would also be x centimeters. What does it mean? That the longitude scale of a Mercator chart is constant throughout the chart. Throughout the chart. I did not say it is constant on all the charts. No. On a given chart, from top to bottom, left to right, one corner to the other corner, the longitude scale remains constant because meridians are equispaced. And this scale here is the longitude scale of the Mercator chart. This is the longitude scale of the Mercator chart. Like the long meridians, the parallels of latitudes are also straight parallel lines, but they are horizontal. They are not vertical lines, they are horizontal lines. But unlike the meridians, which were equispaced, parallels of latitudes are not equispaced. The spacing between the parallels of latitudes on a Mercator chart increases as we go towards the poles. That means as the latitude increases, whether it is northern hemisphere or southern hemisphere, as the latitude increases, the spacing between the parallels of latitudes will also increase. Thus, the latitude scale on a Mercator chart does not remain constant throughout the chart. Why? Because the parallels are not equispaced. It is the latitude scale of the Mercator chart which has to be used as a scale of distance. And every 1 minute of latitude on the Mercator chart will be 1 nautical mile. So when you have to measure the distances on a Mercator chart, please do not make the mistake of using the longitude scale. You have to use the latitude scale. Here is the chart. These are the parallels of latitude. What does it mean that they are not equispaced? That if the distance between these two parallels is x centimeters, distance between these two parallels will not be x, it will be y centimeters. And since the latitude is increasing like this, so in this case, y will be greater than x. And that is what means the spacing between the parallels will keep increasing as we go towards the poles. Here we have the latitude scale, and this latitude scale will be used as scale of distance. So when you want to measure distances on chart, you will use this latitude scale, and you will not use the longitude scale, guys. You will not use this one for distance. You will use the latitude scale for distance. Am I clear, beta? The latitude scale is to be used for distance, and each minute of latitude is 1 nautical mile on the chart. Correct, beta?
Correct, sir.
Done? Oh,
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
yeah. Then the directions on the chart are basically these meridians which run in the north-south direction. They become the reference for the direction. The directions or Mercator chart are measured. We all know how to use these compass roses with our parallel ruler. The compass roses on the Mercator chart are used for measuring the directions. You all have been using them and you know how to use them. In this, the outer graduations are true graduations. We'll talk about them in a while. The inner graduations here, these are the magnetic graduations. We'll talk about them in a while. But compass rows are printed at various locations on the Mercator chart, and you will use the compass rows for the direction part. Now, the directions when we talk in chart work, we will always express them in three-figure notation measured from north, and they will always be expressed in three-figure notation from 0, 0, 0 degrees to 360 degrees. Of course, 0, 0, 0 and 360 are the same. So you may measure them in the clockwise direction. So if you have the north here, the directions will be measured in this the directions will be measured in the clockwise direction from north and expressed in three-figure notation. Now, north, well, you would like ideally the directions to be measured from the true north. True north is the geographical north. What is geographical north, guys? We know that Earth rotates about its axis. So if you have the Earth surface and you have the axis passing through it, wherever it cuts the Earth's surface, these are the poles. Now, these poles are the geographical poles. The one in the northern hemisphere is the North Pole. The other one in the southern hemisphere is the South Pole. So the true north are the geographical north. So this is true north and true south. So true north is the geographical north. Then we have the magnetic north. Now, guys, we know that Earth possesses some magnetism, and the magnetism of the Earth can be considered as if Earth is made of a bar magnet placed at its center. And every bar magnet has a north pole and a south pole. So the direction in which the north pole of the Earth's magnetic field acts is called as the magnetic north. So that will be the magnetic north. Compass north. Now, to measure the directions, you require an equipment. To measure time, you need watch. When you measure time with your watch, is that time accurate? Well, that is accurate, but it will suffer from the error of your watch. So your watch may have some error. Chronometers had error. Every equipment you use has some error. So if you are using compass as an equipment to measure the direction, the compass will have some error. And the direction of the north represented by the compass does not have to necessarily match with the direction of the true north. So the difference between the two will be the error of the compass, and the direction of the north represented by the compass is called as the compass north. Then we gyro. Now, guys, I know a standard compass is also compass. A gyro compass is also a compass. I agree with anybody and everybody who says both gyro and standard compass are compasses. Yes. In chart work, just to differentiate between the two, usually when we say compass, what we are referring to is the standard compass. This is the normal convention we follow in chart work. That's what I'm saying. Otherwise, technically, both are compasses. And when we are talking of gyro, we actually call it as gyro reading or gyro compass or gyro north. So basically, this is what we actually do. So we can have true north represented by the geographical north. We can have a magnetic north. We can have the compass north, that is the north represented by the standard compass. And we can have a gyro north, a north represented by our gyro compass. Now, depending on which of these norths is used to measure the directions are accordingly named. If you measure the direction from true north, then the directions will be referred to as true directions represented by capital T. If you measure the directions from magnetic north, they'll be called as magnetic directions represented by capital M. If you are measuring by standard compass, compass north, then they will be called as compass direction represented by capital C. And if you are using a gyro compass, then they are called as compass directions represented by capital G. So depending on which north is the reference from which you are measuring the directions or expressing the directions, accordingly the directions are called as true directions, magnetic directions, compass directions, or the gyro directions. Now, what do we need to basically first recall? Remember, rather, we all know it. I would not say you have to learn it. You just have to recall what you already know. That how to convert the given directions to true directions. Why? Because what you will be plotting on the chart would be the true directions. So for that, we have to understand what is the error of the gyro or error of the standard compass. Now, guys, error of the gyro compass is in India and this part of the country, even UK, we express it as low or high. I know some of the Eastern Bloc countries, they represent it as East and West. That's okay, doesn't matter much. But your exam, you'll be using low or high. What is the error of the gyro compass? We all know that gyro compass error is named high or low. How do you decide whether the error is high or low? If the gyro value is less than the true, then the gyro error is low. If the gyro value is more, gyro error is high. So the difference between the true direction and the gyro direction is the error, and it has to be named high or low depending on whether gyro is low or gyro is high. Gyro error high means that the gyro value is higher than the true. Gyro error low means gyro reading is lower than the true. Guys, usually I have not seen many people making mistake in this part because you have been using this day in and day out on board also. So I've not seen many people making mistakes here. But then at the same time, you should still not drop your guard, be careful. Accordingly, depending on which is less or which is more, you can convert gyro to true and true to gyro. Let's take few simple examples. Tell me, guys, if gyro course is 265, true course is 267, how much will be the gyro error?
2 degree
2
low.
degree low. 2
2
degrees low.
degrees low. Everybody is good with that? Fantastic. Okay. Then if gyro course is 265 and gyro error is 3 degrees high, what will be the true course?
262.
262.
262.
262 degrees true. Usually, I don't face problems in this part. If the true course is 265 and gyro error is 3 degrees low, then the gyro course is
268. True.
the gyro course is how much? Gyro error
26
is 3 degrees low.
262.
262.
268.
262.
262.
262.
262 beta, gyro is low.
262. Yes, yes.
Yes,
262.
yes. So be careful. That's yeah. So it is. I know you know it, but sometimes you make mistakes in a hurry or something. So you need to be watchful. So this is how the gyro can be converted to true. True can be converted to gyro, or if you know the true and gyro, you can get the gyro error. Usually, we don't face problems in this part of the this conversion. I have not seen many people making mistakes. Those who make mistake, it is basically more of a in a hurry or in just because of rush of time they make mistakes. Otherwise, usually you have been using this on board and you are unlikely to face problems here. What needs to be revisited is this part because this we don't have used every day on board the ship. Error of the standard compass. What is the standard compass? It's a magnetic compass which is mounted in the binnacle on your monkey island. That is the standard compass we are talking about. It's what is its heart and core? Core is a magnetic compass. Why is it called standard compass? Then because it is mounted in the binnacle and the correctors are put to correct the errors. Okay. The error of the standard compass, that is the magnetic compass, is because of two components. One is variation, other is deviation. We'll first deal with variation. Now, magnetic variation at a place is the angle on the horizontal plane between the direction of the magnetic north and the direction of the true north at that place. What does it mean? It means that if you just suspend a magnetic needle at a place, the magnetic needle will align itself because of the Earth's magnetism, pointing in the direction of magnetic north and magnetic south. The axis of the needle will be pointing towards the magnetic north. So if this is the place where I put a compass, a magnetic needle, and let us say the magnetic needle is points comes to rest like this. Now, if this is the magnetic north, then this direction will represent the magnetic north. And if this direction here represents the true north, then this angle between the two is the variation. Now, this is the variation. Now, this variation has two components. One, its value. How many degrees is this angle? 2. It is named east or west. Now here the reference is the true north. So is the magnetic north to the west of true north or east of true north? Now in this direction, if you see the direction of the arrow, it is to the west. So this variation will be, let us say, x degrees west will be the variation in this case. So magnetic variation at a place is the angle on the horizontal plane between the direction of the magnetic north and the direction of the true north at that place. Direction of magnetic north at a place is represented by this needle, and in which direction will the needle point? It will point in the direction of magnetic meridian. Like you have the geographical meridian, what are they? Semi-great circles on the surface of the earth running from pole to pole. Likewise, the magnetic meridians are nearly, not exactly, they are, of course, little zigzag lines. They are the ones running from magnetic pole to magnetic pole. But you can also say that it is the angle at a place between the direction of the magnetic north at that place and the direction of the true north at that particular place, represented by a value and a name east or west. East west will be how the magnetic north is with respect to true north. Direction of the true north at a place is represented by the direction of the geographical meridian at that place. So it can also be said that it is the angle at a place between these two meridians. Thus, it is the angle between the geographical Thus, it is the angle between the geographical meridian and the magnetic meridian at a place, and it is named east and west of true north. So, for naming, what is the reference? True north is the reference from which you will decide whether the variation is west or east. Now, why this variation is there, guys? This variation is there because in the Earth's below the Earth's surface, there are ferromagnetic substances. The deposition of the ferromagnetic substances is not uniform all over the Earth. In some parts, you have heavy concentration of ferromagnetic substances. In some parts, you have lesser. So, the Earth's magnetic field it varies from place to place, and that is what results into this angle changing from place to place. Now you see in this case, if you have true north in this direction, magnetic north in this direction, then obviously the variation is x degrees east. Pay attention to the name. If you have a case like this, the variation becomes west. Now, this is little bit we have tried understanding. Now, how do I get the variation value in my exams? Now, in the exams, the value of the variation you will take from these three possible sources, and it shall be taken in the strict order of priority. Firstly, if the variation is given in the question, you will take that value without any more doubts. So first you will look in the question, and if the variation is given in the question, you will directly use that and close out the matter. If the variation is not given in the question, then you will go to the remarks on top of the question paper. And if you have a variation given there, then that variation will apply to the full question paper and you can use the same variation. If you do not have a variation in the question, you do not have a variation in the remarks on top, then do not waste your time. Do not say variation is not given. You will pick up the variation from the chart. So first you will see if the question provides you variation. If not, you will see on top if the generic remarks provide you variation. If none of them provide you variation, then you will use the chart and pick up the value of variation from the chart. I'll just show you how do we get it from the chart. But is the priority or the order in which you have to decide the value of variation Is it clear? First from the question, then from the remarks on top, and lastly from the chart. Is that clear, beta? Is that
Clear, sir.
clear? Okay.
Yes, sir.
Yes,
Clear.
sir.
Now, for example, if you see the compass rose here, I said when I was explaining the compass rose, this is 000 is the true north. This outer scale are the true directions. The inner scale, if you see this one with this arrow here, this shows the magnetic north at which place? At the center of the compass rose. This direction of the magnetic north is at the center. So this basically magnetic north is for which place? The center of the compass rose. So you see, if you read this part here, what is written here? It is written as 7 degrees 25 minutes. It's written like this in 1994, and in brackets it's 8 minutes east. This is what is written here. What does it mean? That the variation at this place was 7, as west also is here, 7 degrees 25 minutes west, way back in 1994, and its annual rate of change is 8 minutes easterly. So basically, then what will you do? In your answer sheet, you will say like this: variation as calculated from chart. Variation in 1994, 7 degrees 24 minutes west. Change in, so it was 1994, now you are in 24 or 25, whatever it is. Change in 30 years will be how much? 8 minutes east into 30, 240 minutes. Change is 240 minutes east, which is nothing but 4 degrees 00 minutes east. Therefore, current variation will be equal to 3 degrees 24 minutes west, which is approximately 3.5 degrees west. And you can use 3.5 degrees west variation and close out your question. So is the calculation of variation from compass rose clear to everybody, guys?
Variation change is going to towards easterly nose.
Yes, so easterly change. So the change will be 4 degrees east. Am I right? Correct?
Yes, sir.
Correct, sir.
Yes, sir.
And in 1994, it was 7 degrees 24 minutes west. So what will be the resultant left now? It will be algebraic sum, correct, beta?
Yes, sir.
So it will be 3 degrees 24 minutes west, which is nothing but 3.5 degrees west if you round off for use, right? Am I right?
Yes, sir.
Is that clear, Ramchandra?
Yes, sir. Clear.
Okay. So guys, don't get stuck in the hall thinking that variation will come as a correction, and don't waste your time. You can pick up the variation from the chart and close it, but only you have to follow this order. If the question gives variation, then no, don't ask question chart. As per chart, it should be 3.5. The question is giving 7 degrees east. Whatever question is giving, that is overriding everything else. If question is silent, look for it on the remarks on top. And if that is there, that overrides. If nowhere you are getting it, the last resort is you will calculate it from the chart. Which compass rose will you use? You'll use the compass rose closest to the position where you're going to plot. Am I clear? Because in a chart, there will be multiple compass roses. So you'll use the compass rose which is closest to your position of plotting. Is that clear, beta? Is the use of compass rose to obtain the variation clear, guys?
Yes, sir. Clear.
Yes, sir. Yes, sir.
Okay, okay,
Uh,
fine.
Sir, one question.
Tell me.
Why does the variation at a particular place changes every
Beta,
annum?
the variation changes. There are some things called as semi-diurnal changes. There are some diurnal changes. Because beta, the sun activities, the solar activities also keep changing, and these activities of the sun have an effect on the magnetism produced by the ferromagnetic substances which are at the core of the earth. So there are some long term 30-year cycles, some changes are 25-year cycle. There are some changes which are of shorter duration, annual changes. So there are cyclic changes which take place because of these. And again, you see what happens is the Earth's position in the solar system, in its own orbit, its distance from sun, moon, they all keep changing. And therefore, that continues to have effect on the Earth's magnetism. Okay? That is why
Sir,
the
but why it
uh,
will change equally only every year, sir? Just a doubt.
no. This is just an approximate value of 8 minutes of annual change. Because see, there are many changes which are over a long cycle of 30 years or something, which will not have every significant effect every year. But there are many changes which are cyclic of shorter duration, maybe annual or semi-annual. So the result of that at that particular place, they would have found that it is about eight minutes, right, Peter? Because annual changes, you see, the Earth's position in its orbit keeps repeating every year, right?
Yes, sir.
Correct?
Yes, sir.
Likewise, yeah. So that is one simple thing, but the configuration will keep changing with the time. But one reason you can say why it is about 8 minutes every year is because of this. Otherwise, how do they come to this 8 years? They carry out a change. They measure the change over, let us say, 10 years, and the change they will divide by 10 years and come to an average change. Right, beta?
Understood, sir. So it's an approximate change annually.
Correct. So this is what they have determined by reading the changes over a certain period and averaging it out to whatever they have documented here, right?
Understood, sir. Thank you, sir.
Okay, no problem, Tapas. So that is the variation bit. Deviation now. Now, what is deviation, guys? You see, when we suspend a magnetic needle, we found that this magnetic needle, let us say, was pointing in this direction. Now, guys, in schools, you have done an experiment. You must have done that experiment of drawing lines of forces where you had north of the magnet facing north and north of the magnet facing south, and then you took that small compass and continued shifting it and drawing the things. So basically, what happens if this needle is freely suspended? And now, what happens if you bring a magnet close to this needle? Will this needle continue pointing in this direction, or will it be deflected by the magnet that you have brought in the vicinity? Will it suffer deflection, or it will continue pointing in the same direction?
It will deflect it.
It will
It will
deflect, sir.
it will deflect because of the effect of the magnetic that you have brought in its proximity. Okay. Now, what happens is when this compass is placed on the ship is made of metal, and ship is made of iron, which is a ferromagnetic substance. And we also know that if you have a permanent magnet, and close to the permanent magnet, if you put another ferromagnetic substance, you will find that after certain time, magnetism is induced in that substance by the permanent magnet. So now, Earth has a magnetism. Ship is made of ferromagnetic substances. Ship is in the field of Earth's magnetic field. So what will happen? The ship's hull acquires some magnetism. So there is some magnetism induced in the ship's hull. By what? By the Earth's magnetism. Now, this induced magnetism has two components. One, permanent magnetism of the ship's hull, and the second, temporary magnetism. Why does permanent component come in? You see, when the ship is being built, or when ship goes for a long term repairs in a yard, she continues lying facing in the same direction in the Earth's magnetic field for a long time. And the longer it continues to lie in the same direction, more will be the permanent magnetism acquired by it. And then there is always a temporary magnetism induced. Why? Because it's made of ferromagnetic substances. Now you see these lines of forces of the magnet, we know they run from north magnetic pole to south magnetic pole. This we know from what we have learned in our physics and all that. That magnetic lines of force run from magnetic north to magnetic south. Now you see, if a ship has a east-west course, then what do you see? More lines of forces, more magnetic lines of forces are cutting the ship's hull compared to if the same ship was heading north south, lesser lines of forces are cutting it. So the temporary magnetism induced in the ship's hull depends upon the course of the ship. On certain heading, the induced magnetism will be less. On the temporary component, of course, permanent component is permanent. In certain heading, the temporary component will be less. In another, the temporary component will be more. So the ship's own magnetism will depend on the ship's head. Okay. Whatever be the magnetism, less or more is not the issue. Issue is if the ship has its own magnetism, then when you on the ship's hull, on the ship thing, if you mount or like you had this compass needle here pointing in this direction, and now you put it on the ship. Now the ship has come under it and you have placed it on the ship. The moment you place it on the ship's magnetism will not allow the needle to continue pointing in this direction. It will either be deflected this side or it may be deflected this side. This deflection of the magnetic needle from the magnetic north direction to a new direction because of the ship's magnetism is called as deviation. It has been deviated from there. And the new direction in which it will settle, let us say the new direction in which it settles, let us say the new direction in which it settles is this one. Let us say it settles in this one. This was the magnetic north of it, but after it is ship puts on the ship, it points in this direction. This will be the compass north now. So the magnetic needle has been deflected from this direction to this direction. This angle is the deviation. It again has two components, value and name. Now, name is the value is the angle between the two, and the name is east or west, whether it has been deflected from magnetic north. Now, here the reference is the magnetic north. It was initially lying in the direction of magnetic north. It has got deflected from there. So the reference is the magnetic north. If it has got deflected to the east of the magnetic north, deviation is east. If it has got deflected to the west of the magnetic north, the deviation is westerly. So this is how the cause of the deviation is the ship's magnetism. The cause of the thing is the ship's magnetism. So when a magnetic compass is used on board a ship, which is made of ferromagnetic substances, the needle of the compass gets deflected from the direction of the magnetic north to a new direction called as the compass north. The deflection is due to induction of permanent and temporary magnetism in the ship's hull. The deflection from the magnetic to compass north measured east or west of what reference? Magnetic north is called as the deviation. So if you have the true north is this direction, and for at which place? This place. This is the place. This is the place where you are talking about. So if the true north is in this direction, and if you put a magnetic compass here, if it points in this direction, then this becomes the magnetic north. But if this is put on the ship now, it will be deflected in this direction, that is the compass north. So this becomes variation with reference from true north. It is westerly variation. And then from magnetic north, it gets deflected like this because of the ship's magnetism. Here the deviation also is westerly. If you have a case like this variation is westerly, but deviation is easterly. Is the deviation clear? Deviation is the angle between the magnetic north and the direction of the compass north expressed east or west of the magnetic north. Is that clear, beta?
Yes, sir.
Yes,
Yeah,
sir.
clear, sir.
The amount of temporary magnetism depends on the ship's heading, as on different heading, the number of Earth's magnetic lines of forces cutting the hull are different. Thus, the deviation is A, it is ship specific. In the same place on the Earth, different ships will have different deviations. So it is ship specific. And for the same ship, it is also course specific. If the ship is at the same point but her heading changes, the value of deviation will again change. So the deviation is A, ship specific. Two, it is for the same ship, it is also heading specific. Where do we get the deviation from? You get the deviation from what is called as the deviation card or a deviation table. Where is it placed on the ship? It is placed on the chart table. You must, all of you would have seen it, the deviation card or deviation table, which is made when the ship is swung periodically. The deviation card and deviation curves are made. They are used for getting the deviation of the vessel on different headings. Coming to the exam perspective now, in the exams, the deviation will be obtained from the deviation card, which will be provided to you. This deviation card is already included in the that document that I have circulated with you earlier. Now you will enter this deviation card with the ship's head by compass. Please pay attention. You will enter. Why? Because it depends on the ship's head by compass. Guys, when you say card 1, card 2, card 3, card 4, that means they are different ships. They are 4 ships. This is only for exam purposes. On the ship, you will have only one card for your ship. So here, when you have 4 cards, it means there are 4 different ships. We'll be using deviation card 2 in our questions. And please remember, deviation card is entered with ship's head by compass. Ship's head by compass. Now we come to what is the compass error. We wanted to measure directions from here. Then if we use a magnetic compass, that will point in the direction of the magnetic north. What is the error between these two? Error between these two was called as variation.
We
But then
cannot.
that compass, you can't hear me.
The screen is not visible, sir. Screen.
Is it? Let me just see. Let me just see. Screen is not. Is it so
Yes,
with
sir.
everybody?
The
Yes,
slides
I
are
can
not
see.
visible.
You're sharing this.
You can
We
see
can
it.
see.
So, Praveen,
We can see. We can see, sir.
Praveen, can you see it? Who cannot see? Just identify yourself.
The Mridul. I cannot see, sir.
Mridul, you just go out of the meeting, connect again, come back and give me a shout when you're back.
Okay, sir.
Those who are having problems, just go out, come back again. It will be resolved. Praveen, any problem, beta? I can see your hand up. Praveen, any doubts? Mridul, are you back?
सर ये शिप हेड बाय कंपास कंपास नॉर्थ होगा.
एक मिनट बेटा, आ जाने दें इनको. Let him come back. I'll take your question. Don't worry. Mridul, are you back, beta? Mridul. No, he's not back yet.
Yes, sir. I'm back, sir.
Now you can see the screen. I'm moving the names up and down. Can you see that
Yes,
now?
sir, yes, sir. I can see the screen, sir. I can see the screen
Okay,
now.
okay, fine. Praveen, you have raised your hand, beta. Any doubts? Praveen? Ashish, do you have any doubts, beta?
Yes, sir. I just wanted to know, sir,
Uh,
while calculating the deviation card, why we
yeah.
take shift set with magnetic compass, sir?
No, not by magnetic compass. We take it by compass. It's not by, it's a compass head. Why? Because I'll tell you, beta. Deviation is associated with what? Is it associated with gyro compass or standard compass? Standard compass is basically magnetic compass, right?
Yes,
So
sir.
is it associated with gyro compass or is it associated with standard compass?
Magnetic compass, that is a standard compass.
Compass. So that's why you're entering with compass head, right?
Yes, sir.
Okay. Okay. Somebody else was asking a doubt before this a while back. When I said I'll get back to, yeah, but tell me.
The ship head by compass is this compass north.
Yes, ship's head by compass is the compass north. You're absolutely right. Correct. Correct.
Okay, thank you.
Okay. And guys, when you know the variation and deviation, so basically between true north and magnetic north, you have variation. Between magnetic north and compass north, you have deviation. And the algebraic sum of these two is the compass error. Why? Because that will be the difference between true north and compass north. And that is the compass error. Correct? Yes or no? Now, let's see how we quickly convert them, because we can't be wasting time in chart work paper just going through this theory and trying to figure out. Okay. So let me just show you what is on the slide. Then I'll take you through to conversions and we'll have some exercise to revisit the conversion. Compass error at a place is the angle between the direction of the true north and the direction of the compass north. That is the compass error. And you can see it is, in this case, variation was westerly, deviation was westerly. The algebraic sum is the sum total of the two. In this other diagram to the right, variation was westerly, deviation was easterly. Compass error is the algebraic sum of the two. What does algebraic sum means? Algebraic sum means if both have the same names, add the two and retain the common name. If both have different names, subtract the smaller from the bigger one and retain the name of the bigger one. So in the right side direction, westerly variation is more than the easterly deviation. So the compass error is westerly. Compass error is the algebraic sum of variation and deviation. Now, guys, how do we convert? Now we can use a rhyme. Many of you would have heard it right from your pre-C. You may be remembering it also. Now, usually conversion from compass to true again does not, you don't face many problems in this. Why you do not face many problems in this? Because when you have the compass to true conversion, you have the compass course. You will have the variation and you can enter the deviation card with compass course, get the deviation. Algebraic sum of these two will give you the compass error, and compass error can be applied to true or compass and the conversion can take place. So this first conversion usually does not put people to discomfort. This is reasonably okay. Okay. And how do we decide whether to add the error or subtract the error? We can use this rhyme. Error west, compass best. What does it mean? It's only a rhyme which is made for remembering. That if the compass error is west, then compass value will be more. Best means more here. Error west, compass best. Error east, compass least. If the error is east, compass value is less. So error west, compass best. Error east, compass least. This is only because we can keep drawing all the norths and keep figuring out, but in the exam, you don't have the luxury of time to do that. So you'll have to cut short and immediately do the thing. So whether to add or subtract, you can immediately figure out by recalling this rhyme: error west, compass best, error east, compass least. And based on that, you can decide whether to add or subtract. So usually the conversion from compass to true is not at all a problem. Why? Because the difference between compass and true is the compass error. And compass error is the algebraic sum of variation and deviation. Variation will come either from the question or from remarks on top or from the compass rows. Deviation, you will, since you have the compass heading, you can directly enter the table and convert. There is absolutely no problem. The problem that you face is when you have to do it from true to compass. And that is where many people make mistake. Why? Because now you do not have the compass course to enter the deviation table. So that is where you'll have. So please remember that you are told in the class, if the conversion is from true to compass, please watch out. Don't make mistake in a hurry. Because if you make a mistake, it is not expected to be made at this level of management level core exam. If you make a mistake, people don't take it very kindly actually. Now, conversion. True to, if you have to convert from true to compass, you cannot directly go from true to compass. You'll have to basically go like this. Now, let me do it in pen. That is much better. We have the true course or true bearing, whatever it is, true course. We will have the magnetic course and we'll have the compass course. What separates true and magnetic, guys? Which error separates true and magnetic?
Variation.
Variation, fantastic. And which error separates magnetic and compass?
Deviation.
Deviation. Now, when you have to go from true to compass like this, guys, we'll have to go like this. First, I'll go from here to here, and then I'll go from here to here. Okay. So I'll first apply variation to the true course and get magnetic. Now you'll say, sir, how do I decide whether to add or subtract? We can use the same rhyme. What was the rhyme? Rhyme was error west, compass best. Error east, compass least. Now you'll say, sir, here there is no compass. Here true and magnetic are there. And what is the error? Error is the variation. Okay. So now what is the error? Error is the variation. Between this and this, the error is variation. And so if variation is now, and you have two headings, magnet true and magnetic. When we were saying error west, compass best, error east, compass least, we had true and compass. We were converting from true to compass or compass to true if we knew the compass error. Now we are converting from true to magnetic. Error is only variation and true already exists there. So magnetic will take over the role of compass here. So this rhyme becomes variation west, magnetic best. Variation east, magnetic least. So here the compass role will be played by magnetic. And the moment we say magnetic best or magnetic least, we can decide whether to add the variation or subtract the variation to get magnetic from the true. We'll be able to easily decide and then convert the true to magnetic. Once we have the magnetic, we will get deviation. How we'll get deviation? I'll show you through an example. But once the deviation is obtained, we'll again use the same rhyme. What was the rhyme? Error west, compass best, error east, compass least. But now I have to go from magnetic to compass. And now my error is deviation. And I already have compass out here, so there is no problem. I'll compare the compass and decide on plus or minus. There is absolutely no problem in that case. I'll just take an example with you. Don't worry about what is written here. Let's not go through it. Now, conversion, isko bhi chhod do. Now, guys, let me take this example with you. Can you give me some value of the true course that you would like to convert? Give me any value of the true course, beta. What is the true course we want to convert to? Give me some value in
190.
true 190 degrees true. Give me some value of variation, beta. Give me some value of variation.
3 degrees. 3
3
degrees.
degrees. 3 degrees. And what we need is the compass course. So this is the conversion where you have to be careful. So first we'll convert true to magnetic. So what will I write in my answer sheet? I'll write like this. True course is equal to 190 degrees true. Variation is 3 degrees east. Now this will give me the magnetic course. Now variation east, magnetic least. Variation west, magnetic best. Variation is east, magnetic is least. Magnetic least means it will become 187 degrees magnetic. Am I clear, beta? Variation east, magnetic least. Is that clear?
Yes, sir.
Okay, magnetic variation east, magnetic least. So I subtracted and magnetic course became 187. Now to get the deviation, I cannot enter this with magnetic course. I have to enter with compass course. So what we'll do is around this 187 degrees, somewhere in this part, we will modify the table. We'll create a table in my answer sheet. What sort of table will I create? I'll create a table like this. Compass course, corresponding deviation, and when I apply deviation to the compass course, I will get magnetic course. So guys, look, for say 160 degrees compass, my deviation is 1 degree west. For 170 degrees compass, deviation is 0.5 degrees east. Then for 180 degrees compass, deviation is 2 degrees east. For 190 degrees, it is 3.5 degrees east. And for 200 degrees, it is 5.1 degree east. Now I'll apply this deviation to the compass course and get the corresponding magnetic course. So now when I have to apply, the rhyme is what? Deviation east, magnetic least. Deviation west, magnetic best. So here the deviation is 1 degree west. Sorry, deviation west, compass best. Deviation east, compass least. Sorry, my mistake. Deviation west, compass best. Deviation east, compass least. So now tell me, if deviation is 1 degree west, compass is 160 degrees, what will be the magnetic? Deviation west,
159.
compass best. He says 159.
159.
Does everybody agree? Yes or no?
Yes, sir.
Then deviation east 0.5, compass least. So what will be magnetic now?
170.5.
170.5.
170.5.
170.5.
Likewise, this will be 182. This will be 193.5. And this will be 205.1. Now, guys, whatever this table we have created, we'll use in the reverse way. What does it mean? I'll read it like this. If the magnetic course is 159, deviation is 1 degree west. If the magnetic course is 170.5, deviation is 0.5 degrees east. What is my magnetic course? 187. Where will 187 be? 187 would be somewhere here. So I can interpolate now between these two and get the deviation for 187 magnetic. So now you see the deviation changes by 1.5 degrees. For how much change in magnetic course? It is 11.5 degrees, 182 to 193.5. So for 11.5 degrees change in magnetic course, deviation changes by 1.5 degrees. For 1 degree change, the change is divided by 11.5. From 180 to 187, we need a change of 5 degrees. Change is so much. How much is the change, guys? Can you on the calculator quickly multiply? It will be 7.5 divided by 11.5. 7.5 divided by, it's 0.6, right? Am I right, guys? 0.6, correct? Yes or no?
0.6, 0.65.
Yeah, 0.6 degrees, right? So now the change will be from 2 degrees to 3.5 degrees. The change will be 0.6 degrees. So for 187 degrees magnetic, deviation will be 2.6 degrees east. Am I right, guys?
Yes, Yes, sir. sir.
Deviation will be 2.6 degrees east for a magnetic of 187. Now we have got the deviation for 187 degrees magnetic. So this is where people make a mistake because they sometimes in a hurry enter the deviation card with 187 itself and mess it up. You cannot enter the deviation card with magnetic course unless you modify your deviation card like this and have it against the magnetic course. Then only can you use it against the magnetic course. So once you have a deviation of 2.6, you can apply it to this. Error east or deviation east, compass least. Compass least will be 187 minus this. Whatever comes will be your compass course. So have you understood, guys, how to enter the deviation card if you have a magnetic course and then get the deviation? Because this is the
Yes,
place
sir.
where many people make a mistake. So when it comes in the questions, please do take it seriously, practice it, and make sure you don't mess it up in the exams. Now, some of you may ask, sir, when will it be? Why should I learn from true to compass? Why you should learn from true to compass is because if you pick up a course from the chart, that will be true course. And if you're steering by standard compass, then you'll have to know what course should you steer. Therefore, it has a reason why this needs to be practiced. Guys, I'll show you this table now. What you need to do is you need to complete all these blanks. You need to complete these blanks, and then I can show you the correct answers here. For example, if you say here variation west magnetic best, so it will be 109 degrees. Then you have deviation east compass least, that means, or you need the compass error. Okay, compass error will be between compass course and true course. It is 4 degrees. Compass is less, compass least, error east, so this is
East.
4 degrees. This is how you have to fill it up. So you need to fill up all these blanks, and then I'll show it to you. We can discuss if there is any problem you're facing. And once you do that, once you've done this, I'll give you, you can complete this and take a 5 minutes break. At exactly 1900 hours, we'll start with the methods of plotting the position lines. First, I'll cover this. So You can complete
Sir,
this table, take a small break, and then at 1900 hours we'll resume. हाँ बेटा बोलो if there's any doubt.
this is Praveen here, sir.
Yeah, tell
Actually,
me.
due to some obstruction, I'm not able to see the this one screen. Now is
But
it
I was
able
I was
to?
I was giving you a shout. You did not speak either. Then
Sir,
I
actually,
was.
I could not getting the properly. I think some connections or some I don't know what
Then
is
you
happened.
need to check your internet, beta. Your internet speed may be slow. And
Yes, sir. So I
I
just
shouted that you need to log out and come in again in the meeting. The Mradul came
okay.
back and his
Just
problem
because
was
of
resolved.
some
And I was trying to
obstruction,
give you a
I
shout,
just
but you never responded.
not able to see the screens and all. So I
So
just
that
missed this
just check your
opportunity.
internet. Check. It has to be because if it is only you are facing this problem, then it cannot be my internet, beta. It has to be your internet then.
Yes, sir.
Okay.
Sure, sir. Yes.
Okay. Chalo.
Okay.
Chalo na. In the meantime, others can complete this and take a break. Praveen, in the meantime, can you just go out of the meeting and come back again and tell me if you're able to see? Just go
Okay,
out of
sir.
the
Okay.
meeting.
Yeah.
Do that. Are you back, Praveen? Praveen, are you back, beta?
Yes, sir. Yes, sir.
Can you
Now
now
I
see the
come back.
screen? Can
Yeah,
you see the screen?
fill in the blanks. The table is there,
Yeah,
sir. Yeah.
yeah, correct. Now you can see the screen. So this is what you should do. But before you go out of the meeting, you should announce your name that I'm having a problem. I'm going out. I'll come back, sir. So I can wait for you to
Sir,
come back. Okay.
I didn't get recognized, sir. It's gone suddenly. Then I just try to do come back, sir. And
बेटा मैं
by
बोला
the
ना,
time
if you have a problem, the only solution is go out of the meeting and come back again. 99% cases
okay,
it is resolved. Okay.
okay, sir.
Okay. Chalo.
Sure.
Take a break
Yeah.
and complete the table. Okay.
Okay, sir. Yeah. Thank you.
Okay, guys, let's be back. Let's be back, guys. Can we continue?
Yes, sir.
Okay.
Yes, sir.
Yeah, so let's quickly, you can tally it, and if there's any correction to be made, I'll show you the answers. It's 109 and 4 degrees east. Then it's 6 degrees east and 240 degrees. It's 058 and 060, 357, 5 degrees west, 6 degrees east, 10 degrees west, 2 degrees west, 9 degrees east, 093 degrees and 088, 6 degrees east and 2 degrees east, 233 and 222. Any who needs any clarification on any of these answers, let me know, please.
The first one, finally, how did it came to 4 degrees?
Okay, what is the compass error? It's the difference between the compass course and the true course, correct, Vita? There are two ways of getting it. So one, you can compare the true course and the compass course. What is the difference? How much is the difference between true and compass?
4 degrees.
And what is the rhyme? Would you like to recall the rhyme, Ravi once? Ram once?
Compass plus
Compass,
error west.
yeah, and here the compass is less or more
Less.
than the true, less. So compass least, error
East.
east. So it's 4 degrees east. So one way of getting is you can compare these two and give this answer. The second way is you can get the algebraic sum of these two, right, guys? Variation and deviation.
Okay, sir.
Correct? Algebraic sum of 5 degrees west and 9 degrees east will be 4 degrees east. So whichever way you want to get it, it will be 4 degrees east. Right, Ramchandra?
Okay, sir. Thank you.
Okay. So guys, I'm closing this and then we go to the next presentation for the day.
सर ये एक डाउट था सर
Uh, क्या
मैग्नेटिक
doubt था?
नॉर्थ और मैग्नेटिक नॉर्थ और कोर्स नॉर्थ का सर मतलब
क्या?
थ्रू डेफिनेशन
नहीं, क्या डाउट बोलो, फटाफट डाउट बोलो, क्या किस चीज का डेफिनेशन?
डिफरेंस बिटवीन मैग्नेटिक नॉर्थ एंड कॉम्पास नॉर्थ
Difference between magnetic north and compass north. Magnetic north is the north in which at any place, if you suspend a magnetic needle, the direction in which it will point will be magnetic north and south, right? Correct? Correct, beta. So when you have a compass, when you have a magnetic compass and you put it anywhere on the surface of the earth, the direction in which the north of that magnetic compass will point, that will be the magnetic north, right?
राइट सर
Understood? Now, when this same compass is at the same place, now it's put on the ship. Now, it will not continue pointing in the same direction because of the ship's magnetism. It will be deflected, right?
यस सर
Okay. So when this compass is placed on the ship, then the north represented by the compass is the compass north. Correct, Patel?
करेक्ट सर
It will be deflected because of the ship's magnetism from the earlier direction in which it was pointing. Correct?
राइट सर अंडरस्टूड
It is yeah, it is like this, beta. If I put a suppose my compass, my magnetic compass is pointing in this direction, the magnetic north. Here is the compass. So the needle is pointed like this. Now, so this is the compass. Okay. Now below this compass, now I bring my ship. It was earlier the ship was not there. Now when it has come on the ship, this compass needle can be deflected this side or it can be deflected this side depending on what is the magnetism of the ship. So the new direction in which it will point, that will be the compass north, right, beta? Now it has become the ship's compass. It has become the ship's compass when it has come on board the ship, right? Understood?
Yes, sir. Understood.
Okay.
Thank you, sir.
Okay, guys. Now we'll go through different methods that will give us the position lines on the ship. Now, if you see any chart work question, most of the times we'll start with fixing the ship's initial position on the chart. How do you get the position? You will use position lines or position circles. Today we'll learn what are the different methods of getting the position lines, and tomorrow we'll learn what are the different methods of getting position circle. What is a position line? A position line is any line that passes through the ship's position. A line that passes through the observer's position or the ship's position is a position line. In chart work, we often refer to straight PLs. We refer to straight PLs. However, there are some methods which give us non-straight line PLs also. But usually, most of the methods will give you straight line PLs. Now, from our knowledge of geometry in the schools, we know that if I give a piece of paper to all of you in the class and I ask you to draw a line, and I just say draw a line on the paper, everybody will draw randomly. Somebody will be drawing horizontal line, somebody vertical, somebody slanting, somebody in this direction, somebody in that direction. Everybody will draw different line. But if I want everybody to draw the same line on the paper, then that becomes a unique line. And to be able to draw a unique straight line on any piece of paper or chart, in this case, it is possible only if you know a point through which to draw the position line and the direction of the position line. Suppose this is a sheet of paper. If I don't give you any point where to draw the line, every one of you will draw the line wherever you want. But if I say everybody to draw the line through point A, then everybody will draw through point A. But through point A, there can be infinite lines. So again, everybody will be drawing through point A, but the lines will not be same. But if I say draw a line through point A running in the direction north-south, so then I'm sure everybody will come and draw the same line. So that means if I give you a point through which to draw the PL, that is point A in this case, and I give you the direction of the line, then everybody will draw the same line. Am I clear, beta? So if you know a point through which to draw the line and the direction of the line, everybody will end up drawing the unique or the same line. Or in place of that, if 2 points are given through which the line has to be drawn, then we know from geometry that through any 2 points on a plane surface, there can be one and only one straight line that can be drawn through them. So on the same sheet, instead of giving you the point and the direction, suppose I say, this is point C, this is point D. Please draw a line which passes through both C and D. Then whether you draw it or I draw it or somebody else draws it, everybody will draw the same line. So if you want to draw a unique straight line, that will be possible only if either you are given a point through which to draw and the direction of the line, or you are given 2 points through which that line passes. Am I clear, guys? Yes or no? Clear? Okay. In chart work, we will be using the following methods of getting the position lines. We can be getting bearings. Bearings can be visual. You have been taking visual bearings from the bridge wings, or by electronic navigational aids like radar, Earlier, we used to have direction finders, we used to have DECA. You can have those electronic navigational aids. Radar is, of course, used day in and day out to get the bearing. Second is the transit bearing, which can give you a position line. Then opposite bearing, which can give you a position line. Then the sector boundaries of the sector lights, which can give you position lines. The depth contour, which gives you a position line. And the celestial PLs. These are the methods which can be deployed on board the ship or based in the exam, depending on what is given in the question. You can use these methods depending on which method is applicable in a given situation. We shall go through them one by one. Now, PL by bearing. What is bearing? Bearing is the direction of a conspicuous object on the chart taken from the ship. So what happens? The conspicuous object becomes the point through which to draw the PL, and the bearing becomes the direction. So when you know the point through which to draw the PL and the direction of the PL, a unique PL can be drawn. We just saw it a while back. On the chart, only true courses and true bearings to be plotted. Please remember this, only true courses and true bearings to be plotted. If the question gives you compass bearing, question gives you magnetic bearing, compass gives you the question gives you gyro bearing, they must be converted to true. And we just learned before the break how the conversion can be done. So on the chart, you will only plot the true courses and true bearings. The given bearings may be gyro or compass. You must be proficient in converting gyro to true and true to gyro. Compass to true, true to compass. We have just learned it a while back. Later on, today I'm not touching it. I'll also add one more type of bearing later on when we start doing the questions. Relative bearings. The bearings can also be relative and they also need to be converted to true before they can be plotted on the chart. So the bearings may be gyro, compass, or relative bearings. Let's look at it through a question. All of you are aware of this particular part. Plot the following PLs on the chart. Old head of Kinsale light bearing 27 degrees compass, variation 5 degrees west, deviation 3 degrees east. Guys, we cannot plot 270 degrees compass on the chart. It must be converted to true. Likewise, Roche's point bearing 330 degrees gyro, you cannot plot this. It must be converted to true before it is plotted. Let's identify these landmarks on the chart. This is old head of Kinsale light. Guys, how are the lights notated, marked on the chart? Lights are marked like this with a star and the loom of the light. The center of the star represents the position of the light. The center of the star represents the position of the light. So you should not have any doubt which point is the position of the light. The center of the star is the position of the light. Now for Kinsale, we correct the bearing, variation 5 degrees west, deviation 3 degrees east. How much will be the compass error, guys?
2 degree west.
2 degrees west. And the compass bearing was 270 degrees compass. So now, Ramchandra, what will be the true bearing then? If compass error is 2 degrees west and compass bearing is 270 degrees, the true bearing will be Ramchandra?
268, sir.
268.
Error west,
268.
compass best. So it will be 268 degrees true. Very good. Then we had the Roche's point, 330 degrees gyro. Gyro error was given as 2 degrees low. Gyro low means gyro is less. So the true bearing will be 332 degrees true. Now here is the Roche's point light. Here is the old head of Kinsale. We can go to the compass rose, align our compass rose with 268 somewhere here, slide the ruler, bring it here, and plot the PL like this. Am I right, guys? This will be the 268 degrees true from Kinsale, and this will be 332 degrees from Roche's point. You have been plotting these PLs like this. I hope there is no doubt. Am I clear, beta?
Yes, sir, clear.
This is
Yes,
how
sir.
the
Yes, sir.
this is how the PLs will be plotted using the bearing. Only the
Yes.
true bearings need to be plotted, neither the gyro bearing nor the true bearing, and not even the relative bearings. Now we go to the next. PL by transit bearing. What does the transit means? Transit means two objects being in a straight line from you. As they are seen from your ship, the two objects, conspicuous objects, are in a straight line. And we just learned that if they are in a straight line, then there can be only one line joining the two objects, because through 2 points, only one straight line can be drawn. So that is what is transit bearing. Two lights or two conspicuous objects are said to be in transit when both are in straight line as seen from the ship. And if both are in the same direction, that means the bearing of both the objects is the same. I'm sure you'll agree that if they are seen in the same direction from the ship, then the bearing of both of them is the same, and then the objects are said to be in transit. When in transit, the ship must be on the same line. Why? Because if you have a object A, you have object B, you are on this side somewhere, and if you see both of them are in a straight line seen from the ship, then your ship has to be somewhere on this line, then only the two objects can be in the straight line from you. So that becomes your PL. As there is one and this is the concept behind it, as there is one and only one straight line that can be drawn through 2 points on a plane surface, the line joining the two objects extended in the direction of the ship. If the ship was on this side, then it is extended on this side. If the ship was on this side, then this line will be extended on this side. So extended in the direction of the ship becomes the PL. Transit bearings also provide a convenient way of obtaining the compass error. Please remember, when you are doing coastal navigation, transit bearing is a very, very comfortable way of checking your compass error. Any questions on what is written here before we see this through an example, guys? Any clarification required on any of these points? Okay. Don't waste your time in taking out this one. I have a ready video for this. I'll send you the link. You can watch the video based on your requirement. If you're comfortable, don't waste your time. If you need to revisit, you can watch the video. Okay. It is there on the YouTube. Don't worry. Look at the question. At 2000 hours, vessel observes Bellina Corti light and Minehead light to be in transit. When in transit, the bearing was taken by gyro and standard compass. The gyro bearing was found to be 15 degrees gyro, and compass bearing was found to be 018 degrees compass. Draw the 2000 hour PL and also find the gyro error. At the same time, find the error of the compass. And if the variation was 3 degrees west, find the deviation for the ship's head. Now, guys, what will we do? We'll identify on our chart the Minehead light and the Bellina Corti light. This is Minehead and this is Bellina Corti. The center of the stars represent the light position of the lights. Obviously, the ship cannot be on this side. This side is land. Ship is on the sea side. So what will be the PL by transit bearing? I'm sure you'll agree this is the PL by transit bearing. Yes or no, beta? Am I right?
Right, sir.
Yes, sir.
So the transit bearing gives you a position line. Now, if you put your parallel ruler on this, put your parallel ruler here, slide the ruler and bring the ruler here. And what will you read here? This will be the true bearing of both these objects.
bearing.
Yes or no? This will be the true bearing of the object. Correct, beta? From the chart, can you obtain the true bearing of mine head and this Balina Koti? Yes or no?
Yes, sir. Yes.
Put your ruler on the line, slide the ruler to the compass rose and read off in the direction here. This will be the true bearing. So read off 2000 hours true bearing of the lights from the chart. The true bearing from the chart is 013 degrees true. Now this true bearing can be compared with the given compass bearing and the gyro bearing, and you can get the errors. This is how this becomes a convenient method of getting the error without many calculations. True bearing from chart 013 degrees true. Gyro bearing which was observed when they were in transit was 015 degrees gyro. So what is the gyro error, guys? 2 degrees high, am I right?
2 degree high.
2 degree high.
Okay. Likewise, if the true bearing is 013 degrees true, the compass bearing observed by compass was 018 degrees true. What is the compass error? Error
5 degree
error best. Error best.
west.
Compass.
West.
Error best. Compass
Error
west.
compass
West.
best.
5 degree
Yes.
west.
So 5 degrees west. And if the deviation given is 3 degrees east in the question, what will sorry, variation given is 3 degrees east, what will be the deviation?
8
8 degree
degree
west.
8 degrees
West.
west. Fantastic. So that is how the transit bearing becomes a very convenient method of getting the compass error. So if in oral somebody asks you what are the different methods of getting compass error, and especially in coastal navigation, one of them could be transit bearings. Any question on transit bearing being the PL, guys? Clear? Okay.
So why we are not taking the opposite bearing, sir? 013. Why we are not taking the
Okay, where is the ship? Can the ship be on this side, guy? Beta? If the ship is on this side, then only the bearing will be 190 or whatever, right? Am I right?
yes, sir. Understood.
So can the ship be on the land on this side? I said the line joining the two objects extended on the side of the ship. If you remember, I told you. Yeah, I said so, right? Correct. When we were reading what is transit bearing, it said the line joining the two objects which are in transit extended in the towards the direction of the vessel. Am I right?
Right, sir. Right.
So if the ship, then the ship has to, if the ship has to be here or here or here, then what will be the bearing? Bearing will be in this direction. Am I right, Vita? Correct. For this to be the bearing, the ship has to be on this side, north of the lights. Am I right? Have you got your answer, or you still have something bothering you? Is it clear, Vita? Tell me if it is clear, beta. If you still have any doubts, let me know. Who was that? Varun, was it you or somebody else?
Clear, sir. Clear, sir.
Clear?
Clear,
Okay.
sir. Thank you, sir.
Okay, fine. Now we go to PL by reciprocal bearings or opposite bearings. What does opposite bearing mean? Transit bearing means both objects had the same bearing. Opposite bearing means when they are separated by 180 degrees. They are opposite to each other. So you see, two lights or two conspicuous objects are said to be on opposite or reciprocal bearings when their bearings differ exactly by 180 degrees. When on opposite bearing, the ship must be on the straight line segment joining the two objects. In this case, the length of the position line is not indefinite. It is only between the two objects. I'll show you when we are on the chart. You cannot go outside that segment, because if you go on outside the segment, then it can be a case of transit bearing. It cannot be the case of opposite bearings. This is again based on the same concept that between through two points in a plane surface, one and only one straight line can be drawn. Now, unlike other PLs where the line can be extended as much as you want, the length of the position line by opposite bearing is definite. It cannot be extended indefinitely. Opposite bearings, like transit bearings, also provide a very convenient method of getting the position compass error. So this also method during coastal navigation can become a convenient way of getting the compass error. At 2000 hours, a vessel observes hook head light and conic bag light vessel to be on opposite bearings or reciprocal bearings. At the same instant, hook head light bore 293 degrees gyro and 296 degrees by compass. Draw the 2000 RPL, obtain the error of the gyro, obtain the error of the standard compass, and if variation was 3 degrees west, find the deviation. Guys, let's first identify these two landmarks. Here is the hooked light. You all know the symbol for lighthouses. Lights. It's a star with a loom. Here is the conic bag light vessel. What is the symbol for the light vessel? The symbol for the light vessel is like this: a ship made here, right? And here you have a circle, and you have the light shown like this. In the light vessel, this circle at the keel of the light vessel represents the position of the light vessel. So what is the position of the, let me zoom this and show you the light vessel on the chart. Now, can you see this light vessel now, guys? Can you see it here?
Yes, sir, we can see.
Okay. You can see the light vessel here, and this circle. Then can you also see the small circle here? Can you see the small circle here where my dot is now on the screen here? Here, this one. Can
Yes,
you
sir.
see a small circle? This small circle represents the position of the light vessel. Is that clear, guys? The small circle at the keel represents the position of the light vessel, so that there is no doubt as to how the light vessel would show up and how do we know where the position is. Now, if the bearing of these two has to be 180-degree opposite, then guys, this has to be the PL. Sorry, my mistake. One second. This has to be the PL then. Why? Because if the ship is at any point, let us say A, then bearing of, and ship may be heading in any direction, then the bearing of this, say again,
Sir, I
beta.
think there's some problem with your
Okay,
screen. We cannot see.
okay. Screen got unshared. Okay. Thanks. I hope it's visible now. I hope it's visible now.
Now visible,
Is
sir.
it? Okay, fine. Yeah, okay, fine. It got unshared by mistake. Okay. Now see, here is the hook head. Here is the conic bag light vessel. You join them. Now this is the PL. You can't extend this side or this side. Why? Because if the ship is at X, then both will have the same bearing. They will not have opposite bearing. If the ship is at Y, the both will have the same bearing. It will not be opposite bearing. But if the ship is anywhere in between at A, B, C, somewhere, the bearing of the two will be opposite to one another. They will be separated by 180 degrees, because we know a straight line is a 180-degree angle. Am I right, guys? Yes or no? Yes or no?
Yeah, sir.
Yes, sir.
Okay.
Yes,
You
sir.
are right, sir. Right.
That is exactly what the statement was saying, that in this case, The PL will have a definite length. It will be between the two objects. It cannot be extended on either side more than this. Because the moment you extend and go out, beta Pankaj, Preet, mute kar lo, please. Please mute yourself. Yeah, when you extend on either side, then it will transfer. It will no more be opposite bearing then. So when you take the PL by opposite bearings or reciprocal bearing, the PL shall have a definite length, and that is only between the two objects. Now, guys, like the previous case, if you put your parallel ruler on this and slide the ruler and bring it here. So if you are at any point, let's say A, B, C, this bearing will be of which point? Will it be for the hook head or will it be for the light vessel, guys? This bearing on side X will be hook head, and this will be for the light vessel, right? Since the question is giving you the light vessel, this hook head bearing, so we'll take the true bearing of the hook head from here. Am I clear, guys? So again, the true bearing of the hook head or the conic beam light vessel, whichever compass bearings are given, the same true bearing can be obtained from the chart. You see, if the question wanted, so if you take it here, the hook head bearing is 296 degrees true, because when you bring it here like this, it will be somewhere 296, and the conic beam light vessel will be 116. We will be using the hook head because the compass bearings given to us are for hook head. True bearing of hook head 296 degrees true. Gyro bearing of hook head 293 degrees gyro. The gyro error will be 3 degrees low. Am I right, guys? Likewise, now we can deal with the compass error. I am just showing it. I don't think it needs any explanation. If anybody needs any clarification, let me know. And this is how we can get the compass error by opposite bearings. Is it clear, beta? Compass error by opposite bearing, is it clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir. Now, the next we go to is PL by sector boundaries. Beta, just mute yourself. There's some background noise, guys. Please, if you can unmute when you have to talk. Otherwise, please mute yourself. PL by sector boundaries. Now, guys, we know that some lights are visible on a 360-degree horizon in the same color. There are some lights which may be visible in one color over a certain sector, different color over a different sector, another color may be over another sector. These are called sector lights, where they are visible in different colors over different sectors. This is where the colors differ. There may be some lights which may not be visible over 360 degrees horizon. They may be visible over a certain arc and may not be visible over the remaining. They may be obscured. Here also you have sectors, a sector over which it is visible and a sector over which it is obscured. So when you have the colors, there will be a boundary where the color will change from one to another. If it's a question of obscurement and visibility, there will be a boundary. On one side of it, with the light will be visible. On the other side of it, the light will be obscured. So these are the boundaries that we are talking about. So sector lights are the lights that are visible in different colors over different arcs of visibility. In some cases, the sectors may be also of arc of visibility and arc over which it is obscured or arc of obscurement. The boundaries of the sectors of the arcs of different colors or the arc of visibility and obscurement are printed on the chart. These boundaries can act as the PL if we notice when a change is taking place. For example, let us see this, and let me zoom this for you a little bit, and then we'll come back to it again. You see this light, guys. Let me zoom it out for you. And now you can see in this particular light, what do you see? This light is not visible in the same color throughout the arc of visibility. Which light are we talking about? We are talking about Bellinacoti light. We are talking about this light. What do you see? In this arc, it is visible in green color. Here it is visible in white color. From where? This is the boundary which is dividing green from white. Here the boundary divides green and red. Here there is another boundary. So these are the boundaries we are talking about. So have you understood what do we mean by sector boundaries, guys? Yes or no? Clear?
Clear, sir.
Yes, sir.
Now
Yes, sir.
you have to see these boundaries with the ship's course. So let me clear it and go on the screen share this thing slideshow. Now you see here. Now if the ship is going, now let us say this is, let me write here, this is green, this is white, this is red, this is white. Let me call this as sector boundary 1, sector boundary 2, sector boundary 3. Now guys, if the ship is going like this and it observes a change from white to red, then on which boundary the vessel would be if it experiences a change from white to red? Will it be on
Second
line
boundary.
1, line 2, or line 3?
2.
Line
Line
2.
2.
So this becomes the ship's position line at that time. Understood? Clear? This becomes the PL. If the ship was going like this and the vessel observes white to red, then what will be, which boundary will be the PL?
3.
So
3.
3, very good. White
3.
to red, this will be the PL then. Understood? So you have to see it with the ship's course, and then you can figure out which one can be used as the PL at that particular time when the change takes place. Is it clear to everybody? Is it clear, class?
Yes, sir.
Okay. So in the chart, highlight the sector boundaries of Bellinacoti. They are highlighted here. You have the green, white, red, and white. Now look at the question. A vessel is on a northeasterly course. Northeasterly course means something like this. Observes the Bellinacoti light change from white to red at 2000 hours, red to white at 2020.